So this is my YouTube channel Think Max. So show your support by subscribing to this channel and click the bell button so that you get the notification whenever I upload my videos. So you can check out the playlist on my channel. So there are playlists on areas related to circles. So and also the playlist on circles and all the chapter based playlist from class 10 CBSE. So also there is a playlist for math Olympiad questions and there is a playlist for sample question paper. So if you open the playlist, the videos are so you can check this. So there are class 10 max, chapter 7 coordinate geometry, introduction, example problems and exercise problems are all solved in this playlist. So you can check the playlist. Thank you. This is class 10 max chapter 12 surface areas and volumes. In this session we are going to discuss about exercise 12.1 question number 4, 5 and 6. Question number 4. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So what is given? A cube and a hemisphere. So this hemisphere is mounted on the cubical block. So this cubical block is surmounted by a hemisphere. So what is the diameter of the hemisphere? What is the greatest diameter of the hemisphere can have? So if a hemisphere is kept on a cube, what is the greatest diameter it can occupy? So this is the side. So side of the cube is 7 centimeter. So if we keep the hemisphere on top, so this will be the greatest diameter. So this length, that is the length equal to the length of the side of the cube is the greatest diameter. So this hemisphere cannot go out from the cube. So this hemisphere is kept on top of the cube. So the greatest diameter this hemisphere can occupy is nothing but length of the cube. So it is nothing but 7 centimeter. So the greatest diameter the hemisphere can have is 7 centimeter. From this we have to find out the surface area of the solid. So now look at this picture. We can find out what are the portions it occupies. So this cubical block has side 7 centimeter. So this cubical block is surmounted by a hemisphere. So this is the hemisphere. So this hemisphere is kept on the cube. So mounted on the cube. So what is given here? What is the greatest diameter of the hemisphere? So this hemisphere will take the greatest diameter as the length of the side, because just look at this. So we can keep this hemisphere base which is in the circular shape on top. So this full base can be occupied. So this full circular portion is occupied. So what it takes, this is the greatest diameter. So this length which is equal to the length of the side of the cube. So this length will be the greatest diameter of this hemisphere. So this greatest diameter will be the length of the side of the tube, which is 7 centimeter. So the greatest diameter of the hemisphere is 7 centimeter. So first question is answered. Next we have to find out the surface area of the solid. So this solid is in this shape, that is a cubical block surmounted by a hemisphere. So this is the shape of the solid. So this solid takes the shape of the cube. So shape of the cube as well as the shape of the hemisphere. So in this, what happens? The base area of the hemisphere is hidden. Base area of the hemisphere which is equal here. So this base area in the cube is hidden by this hemisphere. So when calculating the surface area of the cube, this area will be included, but this area is not needed. So surface area of the solid will be surface area of the cube. From this surface area we have to take out the base area of this hemisphere, so which is equal here. So we have to take out the base area of the hemisphere. So surface area of the cube minus base area of the hemisphere plus curved surface area of the hemisphere. So this is the required surface area of the solid. Now let us calculate the values. Now we found that greatest diameter of the hemisphere is side of the cube, which is 7 centimeter. So greatest diameter is 7 centimeter. So radius will be equal to 7 by 2. 7 by 2 is equal to 3.5 centimeter. Edge of the cube A is given as 7 centimeter. So edge is 7 centimeter. Greatest diameter. So greatest diameter of this hemisphere is 7 centimeter. So these are the data given. So we have to find out the surface area of the solid. So we know that surface area of the solid is nothing but surface area of the cube plus curved surface area of the hemisphere minus base area of the hemisphere. So because in this cube, so in the cube we include the surface area of the solid. So which this base area will be included. But this base area is hidden by the hemisphere. So we have to take out. So the formula will be surface area of the solid will be curved surface area of the cube plus curved surface area of hemisphere minus base area. So this base area should be subtracted because it is hidden by the hemisphere. So this base area will be included in the cube but it is hidden. So we have to subtract it. Now writing all the formulas. What is the surface area of the cube? Surface area of the cube is nothing but 6a square. So 6a square. Curved surface area of hemisphere is 2 pi r square. Base area is pi r square. So base area is a circle. So it is pi r square. Curved surface area is 2 pi r square. So it is 6a square plus 2 pi r square minus pi r square is pi r square. So 6 into what is A? It is 7. So 7 square plus pi is 22 by 7. So if it is not given, use the value of 22 by 7 into R. What is R? Square, it is 3.5. So 3.5 whole square. So 6 into 7 square is 49 plus 22 by 7 into 3.5 whole square is 3.5 into 3.5. Now calculating what is 6 into 49, 6 nines are 54, balance 5, 6 fours are 24, 24 plus 5 is 29. Plus here we can cancel 3.5 and 7. 1 sevens are 7, 5 sevens are 35, but it is 3.5, so it is 0.5. Now it is 22 into 0.5 into 3.5. So 294 plus what is 22 into 0.5? 2 5s are 10, balance 1, 2 5s are 10, 10 plus 1, 11. So the decimal is before one number. So it is 11.0 into 3.5. So 294 plus 11.0 is nothing as 11. So 11 into 3.5. So 294 plus, so 11 into 35. So if you multiply a number by 11, what are the digits here? 3 and 5. Put the digits and add the two digits. 3 plus 5 is 8. So 11 into 35 is 385. Now the decimal is before one number. So we have to put the decimal before one number. So it is 294.38.5. So 294.38.5. Adding, this is 0.5. So here if there is no decimal, it is 0.0 because after decimal if it is 0, the values are same. So 0 plus 5 is 5, 4 plus 8 is 12, balance 1, 1 plus 9, 10, 10 plus 3, 13, balance 1, 3. So it is 332.5 centimeters square. So this is the required surface area of the soil. Okay children, I hope you can understand this problem. So moving on to the next problem. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter D of the hemisphere is equal to the edge of the cube. Determine the surface area of the solid. This is almost same as the previous problem, but here the previous problem hemisphere is mounted on cube. Here this hemisphere is made as a depression. Okay, so what are the data given? A hemispherical depression is cut out, so it has been taken out from the cubical block. Now the diameter of the hemisphere and the edge of the cube are same. So edge of the cube, if you note it as L, this is same as the diameter of the hemisphere. Now we have to find out the surface area of the remaining solid. Now let us check what are the area it occupies. So this is the cubical part given in this question. So in this cubical block, a hemispherical depression. So this is the part of the depression. A hemispherical depression is cut out. So this block will be looking like this. So outer surface will be in the shape of the cube. On top we will have a hemispherical depression. So there will be portions here. So only this hemispherical depression is cut out. So what are the surface area it occupies? So it occupies the surface area of the cube. So in this surface area of the cube, so this base area which will be in the shape of the square will be included. So but in this square, what happens? This portion. So this portion is cut out. So this base area of the hemisphere is cut out. So we have to include the inner surface area of the hemisphere and take out the base area of the hemisphere. So as in the previous problem, it is nothing but surface area of the cube plus curved surface area of the hemisphere minus. You have to take out the base area of the hemisphere, which will give the surface area of the remaining solid. Okay children, do you understand? So let us get into the problem. Now what is the edge of the cube? So edge of the cube is equal to the diameter L of the hemisphere. So diameter is given as L. So edge of the cube A is equal to L and diameter is also L. So radius of the hemisphere will be L by 2 centimeter. Okay, so these are the data given. Now we have to find out the surface area of the solid. So surface area of the solid, remaining solid is nothing but surface area of the cube plus inner surface area. Inner surface area of the hemisphere, and we have to take out, this is hollow. So this base area is hollow. So this base area should be taken out from the cube. So minus base area of the hemisphere. Now surface area of the cube is nothing but 6a square and inner surface area is nothing but curved surface area of hemisphere, which is 2 pi r square. Base area is circular shape, which is pi r square. So it is nothing but 6a square plus 2 pi r square minus pi r square is pi r square. So 6 into what is a square? A square is L square. So 6 into L square plus an inner surface area of the hemisphere. So hemisphere is pi r square. So pi into r square. R is L by 2 whole square. So you will get 6L square plus pi L square divided by 4. So if we take 4 as LCM, so we have to multiply this number by 4. So 6 4s are 24 L square plus pi L square. So we can take L square by 4 as common. So if we take L square by 4 as common, it will be 24 plus pi centimeter square. So this is the surface area of the remaining solid. So I hope you can understand this problem. With this problem 5 is over. Let us move on to the sixth problem. So sixth problem is a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its end. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. So this is the medicine capsule. Its full length is 14 millimeter. So what are the shapes used in this medicine capsule? So two shapes of hemisphere and one shape of a cylinder. So these two hemisphere are connected to both of the end of the cylinder to form a capsule shape. So its entire length is given as 14 millimeter. Now we have to find out the height of the cylinder. How do we find what is given here? Diameter of the capsule. So diameter means this circular area. So this diameter is 5 millimeter. Okay. So now this data is given. This height of the capsule. Height of the capsule is 14 millimeter and diameter of this hemisphere. So this value is 5 millimeter. So these are the data given. With this data, we have to find out the height of the cylinder. So for height of the cylinder, we have to know the height of the hemisphere. Height of the hemisphere is nothing but radius of the hemisphere. This full length is 5 millimeter. So what about this one? So this full length diameter is 5 millimeter. So radius. So this is nothing but from the center to the circumference, it is radius. So radius equal to 5 by 2, which is 2.5 millimeter. So it is given here. This is also 2.5 millimeter. So this is radius from the center point. Here it is circumference. So this is also radius. So this will be 2.5. So this length will be 2.5 and this length will be 2.5. So totally this is 2.5 and this is 2.5. So 2.5 plus 2.5 is 5. So from 14 we have to take away 2.5 and another 2.5. That is 14 minus 2.5 plus 2.5 is 5. So 14 minus 5 is 9 millimeter. So height of the cylinder will be 9 millimeter. So we got the height of the cylinder and radius of the cylinder and radius of the hemisphere will be same because with this cylinder, this hemisphere of same diameter is attached together. So what happens? Base area of the cylinder and base area of the hemisphere will be hindered. So no need to include the base area of hemisphere as well as the cylinder. Only the curved surface area of the cylinder and curved surface area of two hemispheres are included. Okay, children. I hope you can understand the concept. So let us do the calculation. Now, radius of the cylinder is nothing but 2.5 millimeter because diameter is given as diameter equal to 5 millimeter. So as diameter is 5 millimeter, radius of the cylinder as well as radius of hemisphere both will be 2.5 millimeter. Now height of the cylinder. So height of the cylinder is total height is 40. From this we have to subtract both the height of the hemisphere. So there are two hemispheres attached at both the end. Their height is equal to the radius of the hemisphere, which is 2.5 plus 2.5. So it is nothing but 14 minus 5, which is 9 millimeter. So we got the radius and height of the cylinder. Now we have to calculate the total surface area of the capsule. So it is nothing but curved surface area of the cylinder plus there are two hemispheres. So 2 times curved surface area of the hemisphere. Okay, children. What is the curved surface area of the cylinder? Do you remember? So its formula is 2 pi RH. So 2 pi RH plus 2 into curved surface area of hemisphere is 2 pi R square. So it is 2 pi RH. 2 into 2, it is 4 pi r square. So what is common here? 2 pi r is common. So if we take 2 pi r outside, there will be h remaining. Here 2 will be remaining. 2 into 2 is 4. So 2 and 1 r is remaining. Now substituting the values, 2 into pi takes the value 22 by 7. If it is not given, r will take the value 2.5. R is 2.5. H, height of the cylinder is 9 plus 2 into R is 2.5. So 2 into 22 by 7 into 2.5 in bracket 9 plus what is 2 into 2.5? It is 5. 2 into 2.5 is 5. So now we will be getting 2 into 22 into 2.5 divided by 7 into 9 plus 5 is 14. So 1 sevens are 7, 2 sevens are 14. Now we can multiply 2 into 2.5 which is 5. So 2 into 2.5 is 5. So 5 into 22 into 2. What is 5 into 2? 5 into 2 is 10. So 10 into 22. So it is 220 millimeter square. So this is the total surface area of the capsule. Okay children, do you understand? With this, problem 6 is over. In the next session, we will be discussing about the problem 7, 8 and 9. Thank you.